Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll solve that integral, which is integral between 0 and pi over 2 of cosine x dx divided by 1 plus square root of x, all that to the power of 2. So if I take let u is equal square root of sine x. I know the derivative of sine x is equal cosine x dx. And I have cosine x dx in my numerator, so it's the square root that's bothering me. So here I can take u square is equal sine x. So if I derive u square equal to sine x, I would have 2u du is equal, derivative of sine x is cosine x dx. Now if I look at my integral, I have in my numerator cosine x dx, and here I have cosine x dx is equal to u du. So I can rewrite my integral as 2u du divided by 1 plus u to the power of 2. But because 2 is a constant, I can put it outside my integral. It becomes 2 integral of, instead of u du, cosine x dx, it becomes u du divided by 1 plus, instead of square root of sine x, it becomes u to the power of 2. Now if I look at that integral, I have u in my numerator and 1 plus u in the denominator. Let's rewrite it in a better way. So my integral becomes integral of 1 plus u minus 1 divided by 1 plus u square and all that du. Yeah? Now, because of that minus here, I can split that integral into two integrals. But before doing that, I have to put the borders of my integral here. It used to be between 0 and pi over 2, and when u is equal square root of sine x, so square root of sine 0 is 0, because sine 0 is 0, square root of 0 is 0, so it stays 0 here, and sine of pi over 2 is 1, and square root of 1 is 1, so it becomes 1 here. So my border is between 0 and 1. And now let's split that integral. So it becomes 2 integral between 0 and 1 of 1 plus u divided by 1 plus u square du. And I have the 2 here and the minus 1 here, so it becomes 2 times minus 1 is minus 2. Integral of du divided by 1 plus u square between 0 and 1. So on the first integral here, I can simplify by 1 plus u and take out the exposure of the denominator. So it becomes 2 integral between 0 and 1 of du actually divided by 1 plus u. And here in the second integral, I can say let w, let's write it somewhere else. I can say here, let w equal 1 plus u. So my dw, it become my du, and I can replace that integral minus 2. Instead of du, I can write dw divided by, we said w equal 1 plus u divided by w square. And if I want to find the boundary, when u is equal to 0, w is equal 1 plus 0 is equal to 1. And when u is equal to 1 here, that 1 here, 1 plus 1 is equal to 2, because w is equal 1 plus u. So the first integral here, it become ln of 1 plus u between 0 and 1, and I always put ln between absolute value, because ln of negative number or log of a negative number does not exist, so it always has to be a positive number. That's why we put the absolute value, and minus, and this I can rewrite it here, dw divided by w square. I can write it w minus 2 dw, and the integral of that is w minus 1 divided by minus 1, so it becomes minus 1 divided by w. So here the minus and the minus become plus here, 2 divided by w, because 2 times 1 is 2, and that is between 1 and 2. Now, let's replace u by 1 here first, and then second time by 0. So it becomes 2 ln of, if I replace u by 1, it becomes 1 plus 1, it's ln of 2, minus, if I replace u by 0, it becomes ln of 1. But we know ln of 1 is equal to 0. And for the second one, it becomes plus. If I replace 2 w by 2, it becomes 2 divided by 2, it is equal to 1. And minus, if I replace w by 1, it becomes 2 divided by 1, it is minus 2. So here, ln of 1 is equal to 0. It becomes 2 ln of 2. I don't have to put the absolute value because I know 2 is a positive number and 1 minus 2 is minus 1. And that would be my final answer. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.